When you run a program, it doesn't contain everything inside it. What do you think? The program you write, the logic exactly, only that is present inside executable? No. Many programs depend on external code, like libraries. The hash include that you write in your program, that is referring to a library. So the question is, does the program include that code inside itself, or does it use it from somewhere else? And that's exactly what linking is. Linking is the process of connecting a program with the libraries it needs. Libraries contain reusable code. So that you hash include in your program includes some of the code which is reusable. For example, printing, file handling, math functions. So in different libraries, different kind of reusable code is present, which we can include. And instead of writing everything from scratch, program reuse the existing code. So there are basically two types of linking. First one is static linking. In static linking, all required library code is copied into the executable. That means the final executable contains everything it needs. So let's say you have included one library and only you are using the print function from it. So in your final executable, that print function will be also there along with your program. Right? If a program uses a function from a library, that function is directly added into executable. And that's how the program becomes self-contained. And what are the pros for it? This makes the program independent and it can run even if the library is not installed. But on the other hand, the file size also becomes larger. And if we talk about dynamic linking, in dynamic linking, the library code is not copied into the executable. Instead, the program refers to the external libraries at runtime. And when the program runs, it loads the required libraries from the system. And that's how the executable is smaller, only your code is present. But it depends on external files for those particular definitions that you have used in your program. So what are the pros for this? The file size will be smaller. Libraries can be shared across multiple programs, right? But if the required library is missing, then what? The program may fail, right? So that is the con of it. Now, think of static linking like carrying your own tools everywhere you are going, so you can perform your work. But dynamic linking is like using tools available at the workshop. And if that tool is not present in the workshop and you are totally dependent on it, then you cannot do the work. So that's how it works. And both works, but in different ways. For example, when you use a printf in a C function. So let's say you have written printf hello, and this function comes from a library. So in static linking, printf code is inside your executable. So that .exe file that you make, this printf function will be present there in case of static linking. But in case of dynamic linking, it is loaded from a shared library at runtime. So you will not find this function in the executable file in case of dynamic linking. Now, dynamic linking introduces security risk. For example, library hijacking, DLL injection, and malicious libraries. And if an attacker replaces a trusted library, they can change the program's behavior, because you can take responsibility for your program, right? You are just including that library from external place. And if that is misconfigured or an attacker got the access of that particular library, they can inject their program. So if you are, let's say you are using printf only, but the library in which from which you are referring the printf function is somehow misconfigured, and the printf function triggers something else, so you cannot do anything in this case. So this is dangerous. So static linking is everything inside executable, and dynamic linking is use external libraries. One is independent, but the other is flexible. In the final video of this playlist, we'll connect everything we have learned and see how it all relates to cybersecurity. That's what we are aiming for. And remember, we'll keep it simple.